Everyone having a good day so far? I'm sure it's like an hour old for some of you. Just getting up. All right, here's the deal today. I'm still going to ask for a side length in a right triangle. Pythag's not going to cut it, though. You won't have enough information. And it won't be a 30-60 or 45-45-90 either. And it won't be a Hill-Sass. So what the heck do I do if I can't use anything I just learned from quiz 1? What happens? I need to teach you guys something new. So that's going to happen today. I'm still going to ask you guys to find a side, but none of the stuff we've worked on this unit is going to work for you. All right, so we need another device. Before I show you that device and how we're going to find that side, I got to make sure you have the ability to do something for me. So I have right triangle here, right angle at C. I want you guys to focus on angle A for me right now, please, and answer the following 3 questions with me. If I am looking at angle A, everyone look at angle A. Let's start with this. What would be the hypotenuse of this triangle? It doesn't really matter what angle I'm looking at, right? But if I'm looking at angle A, what's the hypotenuse of this triangle? Name the hypotenuse. 2?
AB.
AB, yep. So let's fill in AB right now for hypotenuse. What would be the opposite side of angle A? The side opposite angle A. Can you identify the side that is opposite angle A for me? 13? CB, good. And I saved this one for last. When we say adjacent, we're talking about a leg. Because I know, right? You could say angle A. There's 2 sides that are adjacent. There's AC and there's AB. But what do we already call AB? What's AB already? Hypotenuse. So when we say the word adjacent, we're looking for a leg. So that would be AC. All right, can you guys do the same thing now for me? But now going from angle B, can you identify those sides going from angle B now? All right, so what would be the adjacent side? And again, you hear the word adjacent, we're thinking about a leg. What's the leg adjacent to angle B? That would be side 6.
CB.
CB, good. What would be the side opposite angle B now? Side opposite angle B. 9. AC, good, yep. And I'm not going to ask process. It's still AB. Hypotenuse never changes no matter what angle we're looking at. All right, everyone okay, identifying the side based on what angle we're looking at. All right, let me introduce you now to 3 ratios that we're going to be using here the second half of the unit. 3 ratios. And again, a ratio, when I say ratio, remember it's, 3 over 4, 2 over 3, 6 over 11. Those are 2 numbers that correspond to each other. So that's what I'm talking about with the ratio here. All right, let me introduce you to the first ratio. Sine. That's how it's actually spelled, but we abbreviate it S-I-N. Please don't say sin. It's called sine. Sine. All right. This right here, I don't want you guys, that's another name for an angle. That's, anybody ever seen that Greek symbol before? In the Greek alphabet? Anybody know the Greek alphabet? Maybe seen that in some frat or sorority houses. Theta. Theta. That's called theta. All that means is an angle measure. Okay, that's all. Don't get freaked out. It's a variable. So the sine ratio. Let me introduce you to the sine ratio. If I ask you for the sine ratio, what 2 numbers do you give me? Well, you give me the opposite side over the hypotenuse, however long they are. All right, the opposite side over the hypotenuse. And we'll do a bunch of these problems here in a second. Okay, so if I ask for the sine ratio, you take the opposite side length and put it over the hypotenuse length. Sine, S-I-N-E, but we abbreviate it S-I-N. And I'm just going to throw all these at you, and then we'll slow down and work on them. The second ratio. How do you think you pronounce that one?
Cosine.
Yeah, right. You good, Nate. Good. You picked up on the last one and put a co in front of it. Good. Cosine. Yes, cosine. And we abbreviate it COS. How do we find that ratio? We take the adjacent side and put it over the hypotenuse side. All right. And then one more. Your third and final ratio. Anybody? Tangent. We abbreviate it TAN. And how do we find it? We take the opposite side and put it over the adjacent side line. All right, so sine, cosine, tangent. I want to help you guys out. I try. You know, sometimes the ice melts off of my heart a little bit once every while and try to help you guys out. This right here is a lot to remember. What is it? What over what? Where's adjacent? Where's hypotenuse? Where does it all go, right? So let me show you a little device that'll help you out. And it's already written on your paper. I'm just going to blow it up. Anybody Pocahontas? Here's my Disney movie reference. Pocahontas? Ever seen Pocahontas? Go in. Okay. Probably? Okay. Do you know anybody know if she had a brother? I don't know if you remember in the movie. I don't know if he was in the movie or not. But Pocahontas had a brother. And conveniently, the brother's name helps us remember how to find these three ratios. SOHCAHTOA. SOHCAHTOA. All right? Pocahontas' brother. How many of you are believing me right now, even though that is 100% false? All right? But it sounds good. All right? Pocahontas' brother. SOHCAHTOA. How can SOHCAHTOA help us remember the ratios? Ready for this? You'll love this one. S for sine. How do you find the sine ratio? What do you think O means? Opposite over hypotenuse. C for cosine. How do you find the cosine ratio? Adjacent over hypotenuse. And then finally, tangent. T for tangent. How do you find tangent? O for opposite over adjacent. The only thing you got to worry about is spelling it correctly. I can't help you with that. All right, but SOHCAHTOA will help you remember what all three ratios are equal to. All good before we try this one at the bottom. All right. Find the sine of angle A. Find the sine of angle A. All right, well, here we go. Sine, abbreviated SIN, from angle A. So the first thing is, before we deal with these numbers 13, 18, and 22, you guys got to help me remember what's the sine ratio equal to. And this is going to be, you got to look back every time, that's fine. Whether you use SOHCAHTOA or you remember, sine is equal to the opposite side over the hypotenuse. Now I just got to plug in the right side lengths. A is where we're going from. So everyone look at angle A. What's the side opposite angle A? 8. How long's the side opposite angle A?
13.
So it's going to be 13 over, what's the hypotenuse in that triangle? 8 again.
22.
So the sine ratio is 13 over 22. And I'm going to show you how we're going to use these in a second. I just want you to find the ratios first. Last thing before we really get cooking here, I will never ever ask you to go from the right angle. You should never be doing any of these problems from the right angle. Why? What if I said what's adjacent to the right angle? We got a problem, don't we? What do you mean? This one right here or this one right here? So I will never ask you to go from the right angle. It will always be from one of the other two acute angles here. All right, so you should never be doing any of these problems going from the right angle. It should be going from one of the two acute angles instead. All right, you ready to get intense now? Hyped up? Let's go. Now we raise it a couple notches. All right, why do I need you to use sine, cosine, tangent? Here's why. Look at example 1 for me. Let's dive right in the fire. Find side x to the nearest tenth. All right, here's what I want to do first. Can I do Hill-Sass? Hill-Sass, anybody? Absolutely not. That's not the type of diagram we do Hill-Sass in. All right, ready? Pythag. It's a right triangle. Anybody? Pythag. Everyone shaking no. Why can't I use Pythag here? Yeah, I don't know anything about BC, so I can't fit everything into Pythag. 30, 60, 90, anybody? Can I use those rules? It's not even a 30, 60, 90 triangle. 45, 45, 90. Nope, it's not that type of triangle. So does everybody see? I'm stuck. Everything we did for quiz 1 can't even use here to find side x. But we can use sine, cosine, tangent. It is still a right triangle. All right, so here's how we're going to do this. You go start from the angle that you are given, the acute angle you are given. What's the acute angles measure that I'm given up here? How many degrees in there? 10? How many degrees in the acute angle? 36. So we're going to focus on 36. And you guys right now are going to tell me, what sides do I have? Do I have opposite, adjacent, hypotenuse? Which sides do I have? All right, again, which sides are labeled? Don't worry about the blank side, BC. I don't care. I want to know what the x is, and I want to know what the 15 is from angle B. So let me start here. Who's got 7? Hi, Kara, how you doing? What do we call side x? That's the what?
Adjacent. Oh, hypotenuse.
It's the hypotenuse. Does everyone agree it's the hypotenuse? So here's what I want you to do. I want you to put an h in parentheses right next to that x. That says, hey, I have the hypotenuse. And what's the 15 from the 36? Look at angle B, 36. What would the 15 be? That's the what side? 7? Opposite. Good, Kara. Opposite side. So we have the hypotenuse and the opposite side. Go back, and this is always going to be up here instead of me flipping back and forth. If I have the opposite and the hypotenuse side, which one of these 3 ratios can I use? If I have opposite and I have hypotenuse, which one of the 3 ratios do I have enough information to use now? If I have opposite and the hypotenuse, what's that ratio called? 11? Nope. 10? Sine. Perfect. Everyone good while we're picking sine? All right. So we're going to use and I'm going to use its abbreviation, SIN. Sine of what angle are we going from? 6. What angle are we going from?
36.
Okay, angle B, which is, you even jumped ahead of me, perfect, which is how big? 36. So the sine of 36 degrees, angle B, is equal to, now write the ratio in the correct order, opposite over hypotenuse. Opposite side over hypotenuse. 1, opposite side is what? 15 over hypotenuse. There you go. So you guys just set up the equation. Now we got to talk about how to solve it. Questions on why we pick sine and not cosine or tangent, and why it's 15 over x versus anything else? Opposite over hypotenuse. All good on the setup. All good. Because I want to take this slow. You ready for solving it for x now? Probably the best thing I'll show you here. Make it a proportion. This is really over what? Nothing's there, so we know it's over 1. How do we solve proportions this year? Cross multiply. Everybody ready? So let's do 1 times 15. So 15 equals, cross multiply going this way, sine of 36 times x. So that's all I did when I cross multiplied. 15 equals sine of 36 times x. Got to get x by itself. Even if you're wrong, who cares? What do you think I have to do on this right side to get x to stay there all by itself? Don't make it complicated. Who's got 9? Okay, I'm going to take a dive. What do you think I have to do on both sides to get x by itself?
Divide both sides by sine of 36.
Perfect. There you go. We're going to divide both sides by the sine of 36. Where do I get this from? That's the sine of 36. Your calculator's got that number for you already. Okay, so let's go to your calculator. Introduce you to a few new buttons. First thing, whoa. Before we start typing like you're texting. Where is it? There it is. This is 36. What type of units? 36. 36 degrees, right? So your calculator has 2 modes for an angle. It has degree mode, and it has what's called radian mode, which we're not going to worry about for a while. All right, we need to make sure, since we're going to type in degrees, that it's in degree mode. So first thing you got to do for me, hit your mode button right up here, mode, and see how mine's on radians. If yours is, move it over to degrees. So highlight degrees and hit enter. So make sure it's in degree mode because that's what we're going to be typing in, 36 degrees. Okay, second mode, you can quit out of that now. And you shouldn't have to do anything else. It's going to stay in degree mode unless you give it to a friend who changes it for you, and then you got to have friends to begin with. You know what I'm saying, Kira? You know? So, okay. So I think it should be in degree mode the full time. Okay? I wasn't talking specifically you. I was just the class in general. You just happen to be in front of me because I know you and your girl are tight here. Yeah. All good? So just leave it. It's in degree mode from now on. All right, let's go back now. So what do I need to do? 15 over sine of 36. So I get my fraction template out. 15 divided by, here are the three new buttons right here. Sine, cosine, tangent that we'll be using from now on in this unit. So we want 15 over sine 36. And then your calculator has that number already in it, whatever sine of 36 is, and we don't need to get into how to get that number, but your calculator has it. And then we just, hey, enter. And you will start to see this unit, we got to really pay attention to our rounding directions because not a lot is going to be in radical form anymore. And what's our directions here? Nearest tenth. So 25.5. And I don't know if I said this earlier in the unit, I'm not a stickler for units. They're not going to take off on the regions if you forget them. I should be a stickler for it in an above average math class, but there's only some battles I picked, and that's not a battle I'm going to fight. So 25.5 for that side. Oh, you're having fun? Is that what I heard? All right, good. Or you're dreading it? That makes me even happier. Good. Yeah. Any questions here before we do another one together? All right, 2. I won't go through why Pythag can't work, 3060, it's not, none of it's going to work, but we can do sine, cosine, tangent. So everyone, what angle are you going to look at? What angle are we going to focus on? 48. We never focus on the right angle, always the acute angle. So everyone focus on 48 and see if you can tell me what side X and 37 is. Opposite, adjacent, hypotenuse. Which ones are they? All right. 6. Who's up? Nate Dog. What do you want to take? I'll let you choose.
36.
36.
37.
37, hypotenuse. So I'll put a little H there next to it. And then what's the side X going to be? 3?
Adjacent.
Good job, Spence. Adjacent. Again, don't worry about the other side. That's not labeled. It's just going to confuse you. So if I have the adjacent side and the hypotenuse, I can use which one of these 3 ratios I've introduced today. If I have the adjacent and the hypotenuse side, I can use which ratio? 9 cosine. Good. So ready? I'm going to abbreviate it COS. Cosine of what angle have we been looking at here? 8. Which angle?
48.
So cosine 48 equals, now go back to SOHCAHTOA. Is it H over A or A over H? SOHCAHTOA will help you out. So what side goes on top here? 3. What side goes on top, Spence?
X.
Adjacent X over hypotenuse 37. Okay, same thing I did in the last problem. Put cosine of 48 over 1, and we're ready to cross these suckers up. So X times 1, I get X. Over here, what do I get? Cosine of 48 times 37. Does everyone see there's nothing to divide out like it was in the previous problem? X is all by itself. X is by itself. There's nothing else to do other than to type this into my calculator. So I go to my calculator. Everyone hits the cosine button. 48. Now, hey, it's important here that you don't do times 37 because your calculator is going to take the cosine of that. I don't want that. Make sure if you're going to put the cosine first, what was it 48 again? You close that sucker up. Close cosine of 48 times 37. And this is what? Nearest inch. Again, watch your rounding. So what are you going to write here? Nearest inch. What is it to the nearest inch? 5?
25.
25. Yep. Okay, how's everyone feeling? All right? All right, let's roll. I think we're starting. Nope, never mind. I was going to say, sorry. Thought we were going to start homework. All right, let's see if we can go through these a little faster now. A ladder is placed against the house with the base at an angle of 75. Yep. State the length of the ladder to the nearest tenth of a foot. So now you got to figure out where to put X. Where's the ladder? It's leaning against the wall, right? So everyone see with the side we're trying to find? Ladder leaning up against the wall. Find the length of the ladder. We're all good here, right here? All right, help me out. We're going from 75. Somebody identify what's the 15 and what's the X up here. 8. What side is 15? Great job. And how about X? Good job, Sophia. Opposite and hypotenuse. Good. We have O and H. So out of the 3 ratios, which ones can we use here? 2. Which one can we use? We have the opposite and hypotenuse. So if I wrote SOHCAHTOA down, what do we have enough information for?
So,
Which S for?
sine.
Sine. So everyone good? Sine 75 equals what side goes where now? 2 again, Nate. Opposite over hypotenuse. So
So 15 over x.
there you go. Let's put it over 1 and cross multiply. Go ahead. $15 equals sine 75 times x. How do I get x by itself in this one? Because it's not 8. Sophia, how can I get x by itself?
Divide both sides by sine 75.
Good job. Sine 75 on both sides. And we're going to the nearest tenth of a foot. Tenth of a foot. Ten, when you're ready, nearest tenth of a foot.
15.5.
Good job. Questions? All right, go ahead, next one. Try it out on your own. Next one. See what you can do on your own. First, what ratio did you pick here out of the three? Which ratio? 5, which ratio did you pick?
Cosine.
Cosine, because you had adjacent hypotenuse. Good. So everyone check your equation. Cosine 40 equals 14 over x. Check your ratio. Check it. All good. Put it over 1. You cross multiply. And then hopefully everybody divided both sides by the cosine of 40. And what are we looking for? Nearest foot when you have it now? Nearest foot, 2. Nearest foot,
18.
18 feet. Good work. Any issue? We're picking this up pretty well until I fool you in a couple questions. All right. All right, 3. BC is parallel to DE. Which ratio is always equivalent to sine of A? Sine of A. All right, so tell me something you know about sine. Sine's equal to what? If you look at SOHCAHTOA, 8. Sophia, what's sine equal to again?
Opposite over hypotenuse.
So that's what I'm looking for. I'm going from angle A, and I'm looking at opposite over hypotenuse. Now, whoa. I'm going to challenge you here, above average kids. This whole sine, cosine, tangent deal only works in right triangles. Only in right triangles. So other than the big one, because there's a right angle there, is there another right triangle in this diagram? There should be. If these are parallel, angle E and angle BCA should be, what type of angles are those? Corresponding, so they should be equal. So you have 2 different right triangles now. So if opposite over hypotenuse doesn't work in one of them, we'll get the other right triangle and do opposite over hypotenuse for those sides. So see what you got here. See if you can find which one's equal to sine A. So take one right triangle and do opposite over hypotenuse. See if those 2 sides are listed. If not, go to the other right triangle. Let me take the big right triangle first. Using the sides in the big right triangle. Take a look. Opposite angle A would be, everybody agree, DE is opposite angle A. Over hypotenuse, which would be DA. 100% correct. But is it a choice? No, that is still correct. That's what sine A is equal to. Still correct, but not a choice. All right, so let's go here now. Let's go to the small right triangle. What side's opposite angle A there? Go ahead, anybody. Opposite angle A?
BC.
BC. And what's the hypotenuse in that right triangle? Is that option there? You're darn right. So it's going to be choice 3. All good? Okay, a couple more here and I'll let you go. Our boy, Big Al, little Mike, the brothers. All right, so Big Al wrote sine 28 equals HJ over 20. Let's talk Big Al first. Is he correct? Is that correct? Is that a correct statement? And they're not asking us to solve anything. It's just saying they wanted to find HJ, so this is how they found it. So let's take a look at Big Al. Did he find HJ correctly? Well, he used sine. What's sine equal to again from today? 4. What's sine equal to again?
Opposite over hypotenuse.
Are they opposite in hypotenuse where they should be? Everyone look at 28. Is HJ opposite? Yep. Is 20 the hypotenuse? Okay, so Big Al's correct. He found it the correct way. Everyone all right? Why? because he used the opposite and hypotenuse and used sine. All right, what about little Mike? He did cosine 60. 62? Where's that coming from?
Yeah, there you go.
What's 62? Where's Mike going from?
Angle 8.
Oh, now he's going from, right? 28 plus 90 and 62 give me 180. So he's going from angle H now. And he's saying he can do HJ over 20. Is he correct? Well, what's cosine equal to again? Cosine? 13 cosine?
The opposite over.
So
Adjacent over.
Yeah, you can use that. Yeah. Adjacent over hypotenuse. So now look, everybody look at 62 degrees. HJ adjacent? Yes? No? It's HJ adjacent to where 62 is. Yep. And it's 20 the hypotenuse? Yes. So they are both correct. Any issues, questions? All right, now I'm going to get you. This is the last one I'll do with you. You can do 6 on your own. Oh, a little ladder leans up against a building. All right, so just make a right triangle. I don't need any fancy looking ladder diagram here. And plus my artistic skills are awful. I'm not going to show those. The ladder forms a 71-degree angle with the ground. And this is where we got to get a little bit more confident in, especially going into tomorrow. Where do I put the 71? The ground. The ladder makes with the ground, not the air. The ladder makes with the ground. Ground is on the right on the bottom. So here's my 71. And the ladder's 4 feet. Where's the 4 going? Everyone knows where the ladder is? Leaning against the wall. How high up the wall does the ladder touch? How high up? So where are you putting your X? Figure out where to put your X. How high up the building does the ladder touch? Well, this is the ground, so there's no way I need the ground, right? How high up the ladder touches? Oh, I'm going to get stumped. I'm going to get you, Nate. This doesn't seem like that bad, right? All right, we go from the 71. Somebody let me know what the X and the 4 is. 13, what's the X? That's what side? Good job. How about the 4? Hypotenuse. This is a basic problem that we've done, right? So far. If I have the opposite and hypotenuse, which one of the 3 ratios can I use? 10? Good work. Good work. Sine 71 equals what over what? So 10 again. X over 4. Good. Anybody want to chime in yet before I finish the problem? All right, hold on, Anna. Hold on. Put it over 1. Cross multiply. X equals sine of 71 times 4. Go to my calculator. Sine button. 71 times 4. What's it say to round to?
Nearest 10.
Nearest what?
10.
Of?
An inch.
I got a problem with your What was your diagram in there, though, kids? That ladder was 4 feet. That's a problem. And I'm going to keep doing this to you, where the units don't match. This was 4 feet. So right now, this answer right here is not inches, is it? It's in what? That's feet. All right, that is feet. So that's going to be 3.7820 feet, not inches, feet. But I need my answer in inches. So what am I going to have to do to this answer here to get the inches? How many feet in it? How many inches in a foot? 12, right? So what am I going to have to do? I'm going to write it all out here for you too. X equals 3.782074302. But that's in feet. I need to go to inches now. So what do I have to do to that? Multiply or divide it by 12? Multiply by 12. Good. Multiply it by 12. And now I round that number. So 45 point, what is it, nearest tenth it says? Yep. So 45.4 inches. I'm going to keep, that's tricky, I know, but I'm going to do that. Let's say you're pretty good in your stealth here. You notice that I gave you feet, but your answer has to be in inches. You could have taken 4 feet, multiplied it by 12, and used 48 inches, and then you would have had no problem. So you have two choices. You either convert it at the beginning of the problem in your diagram, or you convert your answer at the end, but something's got to get converted. All right, I'm going to keep tricking you there. All right, you're on number 6 on your own. Number 6 on your own. And notice the homework comes out of the textbook. You should be getting 3.3 at the end. So see if you can get 3.3 centimeters at the end of this. And then you're good for today. I'm not going to make you get the book with 3 minutes left. So 3.3 centimeters. Let's see if you can get it. Draw your own diagram.